It's time for chemistry. Today we are looking at Graham's law of diffusion. The diffusion of a gas has to do with gas molecules moving from area of high concentration to area of low concentration. Thomas Graham gave us the law of diffusion. Definition of Graham's law of diffusion. It states that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Mathematically, rho is inversely proportional to the square root of density. So if we now introduce a constant, we find that rho root d is equal to k. And consequently, rho1 root d1 equal to rho2 root d2. And so rho1 over rho2 equal to root d2 over root d1. That is the first equation under Graham's law of diffusion. Remember that molar mass is equal to twice vapor density. And consequently, the rate of diffusion is inversely proportional to the square root of its molar mass. So if we introduce a constant, rho will be equal to k divided by root m. And so rho root m is equal to k. And consequently, rho1 root m1 equal to rho2 root m2. And so rho1 over rho2 is equal to m2 over m1. This is the second equation of Graham. Note, rate is volume divided by time. So rho equal to v over t. Now for two gases, rho1 over rho2 will be equal to v1 over t1 divided by v2 over t2. If that equation is evaluated, it gives us rho1 over rho2 equal to v1 t2 over v2 t2. This is the third equation of Thomas Graham. Let's consider an illustrative example. If a gas A is 9 times as heavy as hydrogen, which will diffuse faster and by what factor? The options are A, the gas A by a factor of 3, B, hydrogen by a factor of 9, C, hydrogen by a factor of 3, D, hydrogen by a factor of 1. Now solution. Let's consider the equation rate of diffusion of gas divided by rate of diffusion of hydrogen is equal to the square root of the density of hydrogen divided by the square root of the density of the gas. Rate of diffusion of the gas divided by rate of diffusion of hydrogen is equal to the square root of 9 divided by the square root of 1. And so rate of diffusion of the gas divided by rate of diffusion of hydrogen is equal to 3 over 1. For the square root of 9 is 3, while square root of 1 is just 1. So if we cross multiply this equation, rate of diffusion of the gas is 3 times rate of diffusion of hydrogen. And so it will be seen very clearly that hydrogen will diffuse faster than gas A by a factor of 3. Hydrogen will diffuse faster than gas A by a factor of 3. Now from the solution of example 1, the correct option is C. That is, hydrogen will diffuse faster than gas A by a factor of 3. Let's consider a second illustrative example. 100 centimeter cube of oxygen diffused through a porous partition in 10 seconds. How long will it take 60 centimeter cube of chlorine to diffuse through the same partition under the same condition? Relative atomic masses are given. Oxygen is 16, chlorine is 36. Now the options are A, 9 seconds, B, 3 seconds, C, 18 seconds, and D, 6 seconds. Now, make use of the formula rate of diffusion of oxygen divided by rate of diffusion of chlorine is equal to the square root of molecular mass of chlorine divided by the square root of the molecular mass of oxygen. Now, that of oxygen is 100 divided by 10 60 divided by T, assuming that the time reduction of protein is T. Now, the square root of molecular mass of chlorine is 72 over the square root of molecular mass of oxygen is 32. And so 100 divided by 10 times T over 60 equal to, let's say a common square root, 2 times 36 over 2 times 16. And so if we cancel out, find T over 6 is equal to 6 root 2 over 4 root 2. And so root 2 cancels root 2. And so we now have T over 6 is equal to 3 over 2. And so T is 6 multiplied by 3 divided by 2. 2 divided 2, 1. 2 divided 6, 3. And 3 times 3 is 9. So T is 9 seconds. As seen from the solution to the problem of example 2, the correct option is 9 seconds. And so the answer is A, which is 9 seconds. Example 3. If sulfur 4 oxide and methane are released simultaneously at the opposite end of a narrow tube, the rate of diffusion of sulfur 4 oxide and methane will be in the ratio. Now, given the relative atomic masses of sulfur to be 32, O to be 16, C to be 12, and H to be 1. The options are A, 1 to 2, B, 2 to 1, C, 1 to 3, and D, 3 to 1. We are making use of the formula rate of diffusion of sulfur 4 oxide divided by rate of diffusion of methane is equal to the square root of molecular mass of methane divided by the square root of molecular mass of sulfur 4 oxide. And so we have rate of diffusion of sulfur 4 oxide divided by rate of diffusion of methane. Now, the molecular mass of sulfur 4 oxide is 32 plus 32, that is 64. And the square root and the relative molecular mass of methane is 12 plus 4, that is 16. And so, rate of diffusion of sulfur 4 oxide divided by rate of diffusion of methane. Now, the square root of 64 is 8, while the square root of 16 is 4. And so, rate of diffusion of sulfur 4 oxide divided by rate of diffusion of methane is equal to 2. And so, rate of diffusion of sulfur 4 oxide is twice the rate of diffusion of methane. As seen from the solution above, the rate of diffusion of sulfur 4 oxide to that of methane is 1 to 2. And consequently, the correct option is A, 1 to 2. Let's consider a fourth example under Graham's law of diffusion. It reads, a given volume of methane diffuses in 20 seconds. How long will it take the same volume of sulfur 4 oxide to diffuse under the same condition, given that the molar mass of methane is 16 and that of sulfur 4 oxide is 64? The options are A, 4.0 seconds, B, 40 seconds, C, 50 seconds, and D, 5 seconds. We make use of the formula rate of diffusion of methane divided by rate of diffusion of sulfur 4 oxide equal to the square root of relative molecular mass of sulfur 4 oxide divided by the square root of relative molecular mass of methane. Now, rate of diffusion of methane, let's assume that the volume of methane is V over 20 divided by rate of diffusion of sulfur 4 oxide. Let's assume that the time is T. And so the relative molecular mass of sulfur 4 oxide as given by the problem is 64, and that of methane is 16. And so V divided by 20 multiplied by T over V is the square root of 64 is 8, but the square root of 16 is 4. And so V cancels V, and so T divided by 20 is equal to 2. And so if we cross multiply T equal to 40 seconds. Now from the solution to example 4, the correct option is 40 seconds. And so looking at the options, B is the correct answer.